Bismillahirrahmanirrahim. So this is 0625 IGCSE Physics, paper 6. We had done questions 1 and 2 the last time. So here's question 3. A student investigates the magnification produced by a converging lens. He is using the apparatus shown in figure 3.1. We can see that here is the source of illumination, right? And you have an illuminated triangle which is shown over here, right? Then there's a lens and a screen on which the image will form. The illuminated object consists of a triangular shaped hole in a piece of card. Figure 3.2 shows full size the illuminated object. Okay, so this is the card. As you can see, the gray area, and they've cut a triangular piece out of it. Measure and record the height of the triangular shaped hole. Now, obviously, this is something that you would need to do on paper, and for this, you would need a ruler from a good manufacturer, right? So don't buy one that is just like a ruler. Get one from a good stationery manufacturer like Staedtler or Pelican or Maped or any one of those,
Yeah.
because they are calibrated appropriately. So when you
Yeah.
measure this, obviously we can't do it right now. So when you do measure this, you will get 1.4 centimeter,
Oh, okay.
right? We do have a measure option, but it's all premium, so yeah, can't do this. So that's 1.4 centimeter. Now, the distance between the illuminated object and the center of the lens is set to U 20 centimeters. The screen is moved until a focused image of the illuminated object is seen as shown in figure 3.3. Now, the first thing you would notice, obviously, is that the object is upright, so to speak, right? The base is at the bottom and the point is up top, whereas the image is inverted, right? And that means that the image is real. Okay.
Yeah.
So the distance between the illuminated object and the center of the lens. So this is what they're talking about, U. Okay. That is set to
Okay.
20 centimeter. The student repeats the procedure for 30 centimeter, 40, 50, and 60. Right? His results are shown in table 3.1. Measure and record in the first row of table 3.1 the height of the image. Right, so the height of the image, again, we need a ruler for that. I do not have the option in the app, and so unfortunately we just have to take that uh, from the mark scheme. Right, and it's supposed to be about 4.5 centimeter. Right, now what's the magnification going to be? And so the magnification is what's the formula for magnification?
Is it the one written there?
Yeah, so they have given it here. I actually did not read that part.
Yeah.
Right, so it's object height or object size over image size.
Okay.
Right, and so we had 1.4 and now we've got 4.5. So what are we getting out of that?
Uh, just a minute. Um, Sorry, just taking a moment to calculate.
Is your calculator slow? It's really taking that long.
It is it 0.3111?
Yeah, but we only write 0.31 to two significant figures.
Yeah.
Okay, so you get that. Now, plot a graph of u centimeter on the y-axis versus magnification on the x-axis, right? So let's see, you have 20, 30, 40, 50, and 60. Okay,
Yeah. Okay.
and you have from 0 up till 3. So 1, 2, 3. So yeah, this is nice. Now, they do tell us that you do not have to start your axes at the origin, meaning 0 and 0, right? So this is, well, let's start over here at 10 centimeter. So that makes it 20, 30, 40, 50, and all the way up here 60, right? That's for the y-axis. For the x-axis, I can start at 0 and then 1, so that's 0.5, and 1.5, and 2.0, so that's 0.0, then 2.5, and then 3.0. And so we are using 100% of the graph, right? Normally, what you're expected to do when you're supposed to plot a graph is use at least 75% of the area. Okay. Now you need to label the axis. So this is, right, u per centimeter, and this is n.
Yeah.
And so you put in the points. So the first thing we have is 20 and 0.31.
Yeah.
So that's 0.1, 2, 3, and somewhere over here. Now for this, I need a finer pencil line. So let's go to 0.5. Okay, so 0.31 should be somewhere over here. Then we have 30 and 0.93. So
Okay.
0.9 is over here, and 30, and so 0.93 should be somewhere over here.
Okay.
Yeah, because right now I'm the one solving the paper.
Yeah.
Okay, then we have 40 and 1.6. So this one's easy. You got 1.5 over here and 1.6.
Why did we not use whole numbers
For which one?
for like the x-axis?
Well, you see, what you need to do is you need to see what range do you need.
So okay, if the m were whole numbers, you would be giving whole numbers in the x-axis. But since it's not, it's in decimals. We gotta do
Well,
it.
I have taken whole number as in 1, 2, and 3, right? But
Yeah,
yeah, so I've taken like one large square, or 10
yeah.
or 10 small squares should be 0.5. And what this does is it makes the marking very easy for me, right? Because I've got more space on the graph for smaller units.
Yeah,
I could have just gone 1, 2, and 3,
yeah,
and so that would have made this 0.5, and so finding 0.61 would have been very difficult,
yeah.
right? So you want to label like the axis that the scale of the axis should try and utilize not only the maximum area of the graph, but should also be such that you get nice working range, right?
Okay.
You can easily mark it. So far,
So
yeah,
the point that you made between 0 and 0.5, what point is that?
this is
The mark.
0.61 over here, right?
Okay. Yeah, yeah,
This is 0.61, this is 0.93, this is 1.6.
yeah. Okay.
Yeah, I'm getting it from here,
Yeah, yeah.
right? So next is 50
That's
and
that.
2.3. So that's also easy. We look at 50. So 2.3 is over here. So we just go up. And so that is 2.3 and 50. And finally 60 and 2.8, right? Which is here.
Okay.
Right now you're like, okay, if you say so.
No, I mean, yeah, I mean, it's easy. Yeah.
No, this is easy because you're seeing that it's linear.
Yeah.
Okay. Now what we need to do is draw a graph, right? So let's see what they're asking us to do. Determine the gradient. So first plot it, right? And so that's 4 marks. So the axis gives you marks, the labeling gives you marks, right? And then the actual line gives you marks. The actual line, right? It is
Hmm.
always a line of best fit. Okay, so just let me go back to 1 point over here. So it's always a line of best fit, right?
Best fit meaning.
Meaning that it's not necessary that all your points are following exactly on the line, right? It could be that the points are slightly scattered, and so what you do is
Oh,
you
okay. They don't have to be a straight line.
no, you're going to draw a straight line. You're
But
going
the
to
dots don't have to be in a. The
Yeah,
dots don't have to be
they
in a
don't
straight line.
necessarily have to be in a straight line. So what you're going to do is you're going to sort of approximately draw a line through the points, right? So that it's falling between them, so to speak,
Yeah.
right? So that's called a
Yeah. The
line.
dot could be wobbly,
Yeah,
right?
I mean, sort of scattered around the line. If that's what you mean by wobbly, then yes, more or less. Okay, so
Okay.
let's try to draw this. As you can see, it's that looks like a best. Does that look like a best fit line to you?
I mean, there's one dot left behind, but okay, that's fine.
You can see if I just zoom in, right? This dot is below the line, right?
Yeah.
I'm joining this dot, right? So it's
Hmm.
not exactly going through any of these.
So does that make you lose marks?
If you've drawn it well enough, then no.
Okay.
Let's try
So
this again.
anyway, yes. Okay.
See, if I try to, well, one thing you don't want to do is just like take the first and last point and join them, because now what you see, your line is going through 3 points, but 2 points are below the line. Okay.
Yeah. Yeah.
So again, this looks okay to me. Kind of.
Yeah. I mean, at least all the dots are touching the line, if not through the line. That was fine, sir.
Yeah, I'm kind of a perfectionist. Plus, this is an app, so I'm kind of slightly annoyed by this. Okay, let's stick with this for the time being. Let's see how we do. Now they're asking you to get the gradient.
Okay. Oh, do I need to tell the gradient formula?
Hmm?
Do I have to tell the gradient formula, right?
Yes.
So it's y2 minus y1 divided by x2 minus x1.
So now we need values, right? Let's take some easy to use values, shall we?
Hmm.
So let's take, for example, 2,
Okay.
right? 2 on the x-axis. So if we take 2 on the x-axis and we follow that and we go up here, so we're saying over here, oops, that's thick. So 0.5 again. So over here,
It's not exactly on a line, it's in between the box.
yeah, that's fine. So if we follow that, if we follow that over here, right? It's here. So what's that value? So you've got 40, 41, 2, 3, 4, 5, 6, 46.5,
Okay.
right?
Yeah.
And then we take 1, or you could take 1.5 if you, which one do you want? Let's take
Let's
1.5.
take let's take one since you chose two, right?
Okay, so if we take 1, right, this is, and so if we follow that, it's 30.5 over here,
Hmm.
right? So 46.5 minus 30.5, 46.5 minus 30.5 divided by 2 minus 1. And so that's giving you 16.
Let me check on that. 45.5 minus,
46,
right?
46.5.
Okay, 46.5 minus, what is the other number?
30.5.
30.5. 30.25.
Eh?
Yeah.
46.5 minus 30.5.
Yeah.
46.5
I
my,
I did the I did the whole thing like divided by 2 minus 1.
no, then your calculator's messing something up. Okay, what is 2 minus 1?
1.
Yeah, so you don't need the denominator. Just
Yeah.
do, you just do 46.5 minus 30.5.
Okay. 16.
Yeah, so what's 16 divided by 1?
16.
Exactly. Now the expected answer is between, oh, by the way, 16.0. So the expected answer is between 15.0 and 17.0, which means I did a good job with the line.
Yeah.
Okay.
Yeah.
I'm going to pat myself on the back because I'm the one solving this paper. Okay. Other than
And
that,
not me.
huh?
Not me.
Well, you're a spectator at this point.
Okay.
Okay. Another thing that you need to do, which I haven't done, right? So let's just do it quickly, is you need to draw dotted lines again with a ruler. I'm going to do it freehand because I don't have a ruler.
Oh gosh.
Yeah, and so you can see that's not going well. You draw dotted lines showing your points. So obviously you can see that's not going all too well. But yeah, be better on the last one. There. All right, so that's for the y values, and then for the x values, zoom out, and yeah, so right, you got that and that. So you don't need dotted line over there. You already have those. Okay. And so you need to show those dotted lines for your values. Then you did the calculation, getting 16, which is an acceptable answer. And so we're good to go.
Okay.
Now, describe one difficulty that might be experienced when measuring the height of the image. Suggest an improvement to the apparatus to reduce this difficulty.
I mean, since you're solving, you go ahead.
Well, no. Now you need to participate.
Okay, let me think. Mm, I don't mind getting help. Actually, I'm not really.
So a difficulty in
Blurry or
a
faint
difficulty in
edges.
measuring the height of image font on the screen.
Yeah, so it can be the image can be blurry or faint edges.
The image is faint.
Yeah, or blurry.
So if you're going to suggest that, then what improvement will you also suggest?
Uh, if improvement, it would be, let's see.
The improvement should match the difficulty.
Oh, okay. So no, wait. Let me change my difficulty.
Yeah,
Uh,
obviously. I mean, if you're highlighting a difficulty, then the improvement should be for that difficulty.
okay. Wait. Let me think. Okay. So like the observers, like the one who is observing, the observer's hand or ruler can cast a shadow over the image while measuring.
Okay. So
And so
hand.
for that, you need to use a translucent screen and measure the image from the back so the ruler or the observer does not block the light.
So the hand can cover screen while measuring. HI. And so the improvement is what?
The improvement is use a translucent screen and measure the image from the back so the observer doesn't block the light.
Did you come up with that all on your own?
I took a little help,
Uh-huh.
but the idea was mine.
So trans
I did not know how to explain it into words, so I needed to, form out sentences better.
Translucent screen and measure from behind screen. Okay, so we're done with that. Now is the last question, which is the planning question in physics. So we already
Oh,
experienced the
damn.
planning question in chemistry. So a student is,
Uh,
yeah, go ahead.
okay. Okay, never mind. Let's. I may need a help if you don't mind.
Yeah, of course, that's what I'm here for.
Okay, yeah, let's go.
So a student is investigating the factors that affect the size of the crater a ball makes when it is dropped into the sand. So do you understand what's happening over there?
No.
You've got
Wait.
sand and you've got a
Okay.
ball that's
Yeah.
being dropped into the sand. And when that
Oh, so
happens,
that makes a hole in the sand.
yes, right? So there'll be
Okay.
this depression is the hole that the ball is making. So, right, that's what being is investigating the factors. What affects the size of the crater, not the size of the ball, right? The size of the crater or the hole that's being made in the sand when the ball drops.
Yeah.
Plan an experiment to investigate one factor that affects
Okay.
the size of the crater. Right, the apparatus available includes metal balls of different sizes, a tray of dry sand. Okay, write a plan for the experiment. In your plan, you should not the bullet points that they're giving. If you answer each of these bullet points, how many bullet points are there? There's like 1, 2, 3, 4, 5, 6, right? And the question is worth 7 marks. If you answer all of these correctly, right, you get your marks,
Okay.
right? So state which factors being investigated. So you got metal balls of different sizes, right? Different sizes can mean, right, different mass as well. You can investigate that, or you could investigate, for example, the height from which the ball is being dropped, right? So, right, state a key variable to keep constant. Now that depends on the factor that you are uh, measuring, right? If you're going to change the mass of the balls, what do you need to keep constant?
If you want to what?
If you're going to investigate the effect of balls of different masses
Yeah.
and the hole that they make in the sand, so that you're going to use balls of different masses, so that is a variable, right? When doing
Yeah.
that, what are you going to keep constant, what are you going to keep the same?
The height,
Exactly. And if you're going to check the height, then what are you going to keep the same?
the mass.
Exactly.
Okay.
Right? So if you're checking the effect of height, then you're going to use the ball of the same mass. If you're going to check effect of mass, then you're going to keep the height from which you're dropping the ball the same. List
Okay.
any additional apparatus needed. So for example, you need like a ruler to measure the size of the hole, for example. Excuse me.
It's fine.
Explain briefly how to do the experiment, including what is measured and how this is done. Okay. State how to obtain reliable results. So reliable means repeat,
Okay.
right? So for each height or each mass, you take at least 3 measurements. Suggest a suitable graph.
Okay.
Suggest a suitable graph to be drawn for the results, right? So you can do, right, mass mass of ball in grams, right, versus size of the hole in centimeter or millimeter, depends, right? Or you could do height, right, of ball drop, again versus, so height of ball drop in centimeter against in centimeter versus size of hole in millimeter, right?
Yeah.
You may draw a diagram if it helps you to explain your plan, right? So
I
that's,
mean, do we need to?
it's always helpful. Like I explained in chemistry, drawing a diagram will support your explanation.
I mean, how would I draw? I'm not like I cannot draw based on the sentences.
Can, right? So first, let's try to explain this, right? And writing in bullet points will help, right? So what are you choosing? Are you choosing the mass or the height?
I mean, what's more easier?
It doesn't matter.
Okay, let's just go with the keeping the height same.
So we're going to take balls of different mass,
Yeah.
right? So we're going to investigate the effect of mass of metal balls on size of crater formed in sand, right? So we're going to take, for example, 5 metal balls, right? And you are going to measure their mass using a mass balance. Okay.
Okay.
Take the first ball to a, right, sorry, not take, hold. So hold the first ball at a decided height above the tray of sand. Release
Yeah.
the ball
Into the tray of dry sand.
so it falls into the tray. Measure the size of the crater formed using at a decided height in, right, centimeters. So you mentioned that.
Yeah. And
Fine.
then we have to
Using
smooth the sand surface again so it perfectly flat again.
a ruler, right, in millimeter. Record the value in a table. Right. Smoothen the sand surface before the next
Repeating the process.
investigation. Yeah, so repeating the process. Repeat the process for the remaining 4 balls keeping the height of the drop the same.
Okay.
Right? Record all results in a table to increase reliability. Repeat the investigation for each ball of measured mass twice. Right? Repeat twice. So a total, so you measure that, you mention that of 3 values are obtained. Take a mean. Mean means
Mean means. Wait, I did learn this in maths.
average.
The average. Yeah. Look how smart.
Uh-huh.
Yeah.
Take a mean
Don't
value.
doubt me.
Take a mean value of size
Don't underestimate the power of a common student.
of a what student?
Of a common student.
A common student.
Yeah.
Take a mean value of size of crater for each mass of ball used, right? And then plot a graph of right mass mean. So, right, the independent variable should be on the x-axis. That is the mass. So the mean mass of, not the mean mass, sorry, the mass of ball, right, in grams on the x-axis versus mean size of crater, right, in millimeters on y-axis. Right, so I forgot to mention I measure their mass using a mass balance in grams. So 1, 2, 3, 4, 5. Acha, you're not going to get marks according to how many bullet points you've written down, right? You
Uh,
are going to get marks according to whether you are satisfying the criteria of the question.
okay.
So,
How many points have you wrote up until now?
huh?
How many points have you written?
How many points? Let's see. So, right, 7 marks. There are seven, right, different points to. So the first is, right, which factor are you going to test? So clear statement
We
for,
wrote only three.
huh?
We wrote only three.
Eh? What do you mean?
We wrote on 3 points.
Yeah.
Oh, okay. You haven't scrolled up. Okay, okay, know that.
One, two. These are not points. I've broken it down into bullet points, but that doesn't mean that each one is going to get a mark. So I'm going to tell you what the
Yeah.
criteria is.
Okay.
The first mark is for clearly stating which factor you're going to measure. So we did mass of ball. Okay.
Okay.
The second is to clearly state which variable we are going to control, and that is
Which
right,
is the height.
the height of the drop.
Yeah.
Okay. Then is to mention the apparatus. So we mentioned we needed a ruler, we mentioned we needed a mass balance, right?
Yeah.
Then is the method. So for example, measure the factor.
Method as in like we how we do the how we
So
like
so
check the
we,
mass.
yeah, so we measure, we mentioned measuring the mass, we mentioned measuring the size of the, actually one mistake that we've done, right, is record, measure the size. So what do you mean by size of the crater, right? So over here, right, we probably not get a mark for this, and so to correct that, we're going to write diameter.
Yeah, I was gonna say that. I'm like, okay, wait.
Okay,
Yeah.
so we need to be clear about that. So measure the diameter. Okay,
Okay.
then you mentioned that you repeat for the other balls and test them. So far we've done all of that and we're getting 5 marks so far, right? Then additional point is for the sixth mark, and that is get a mean, like repeat. So reliability is repetition. So repeat for each factor, value factor, and then get a mean and all of that. Okay, so we got that as well. We mentioned that as well. And finally is the graph, right?
Okay. Yeah.
And so we mentioned the graph as well. So we will be, right? So mean diameter, again over here, instead of size, it should be diameter, right? And if you do that, if you correct that, then we will get all 7 marks.
Okay. Got that.
So this is how you, right? So the experiment that, like, was it difficult at all?
I mean, no. Um, Now that you describe it in a like stepwise way, it was easy.
Yeah. So this is what you have to do,
Okay.
right? Now, obviously, it's not going to be the same experiment. It's going to be a different scenario. It is going to test your concepts, and it is going to test whether you can sort of imagine yourself doing that and what you're going to measure, what you need to measure, what instruments you need. And so you need to detail it the way that I've done it over here. And as I checked it against the part schemes, so the only mistake I made was say size instead of diameter. Otherwise, everything else, right? You measure, you mentioned the apparatus you need, you mentioned how to do it, you mentioned the unit in which you're going to take your measurement, and etc etc, and you, and like these are easy marks.
Yeah. Okay. Got that.
All right,
Yeah.
so over here as well, right, diameter. All right, so we are done with that, and so tomorrow we can start with another paper one,
Okay.
right?
Yeah.
All right, so I'll see you next time, inshallah.
Inshallah. Okay. Allah Hafiz.
Allah.